Good morning. So we are working on section 2.2, so linear regression. So that is what we are talking about today. And it's how can you use scatter plots to predict future trends. So I just want to let you know, so we're going to use the data that we used last time. So this is the data that we wrote this down, everybody. So this is the data for Sophia's running a concession stand selling water bottles. She keeps track of each day's high temperature and the number of water bottles sold. So that is the data that we are going to use. Okay. So we're going to use that data. So linear regression, everybody. Let's see it. So linear regression is just a fancy word for the line of best fit. So you see that word linear has the word line in it, so line of best fit. Okay. And so we already did our steps. Okay, so we already put in our data. Okay, if you want to go ahead and do that again just to practice, that is excellent. Okay. So I am actually going to go to decimals.com. And I'm going to go to the plus sign again, everybody, and I'm going to do table. So I am going to look at my notes and I'm going to put in that data again. Okay. 5 degrees, she sold 102. It's 71 degrees outside. She sold 133. And everybody, I suggest you do this along with me just to make sure that you got this. 79 degrees, sold 144. When it was 80 degrees, sold 161. When it was 86 degrees, she sold 191. When it was 86 degrees again, she sold 207. When it was 91, she sold 235. When it was at 95 degrees outside, sold 237. When it was 100 degrees, she sold 234. Okay. And then this is where we go here, and we're going to use the keyboard. So I'm going to put in Y. Y1 is equal to, and then that's where we have to go this ABC. I'm going to do M X. I have to add the number 1 plus. Okay. B. Oh, sorry, y'all. Actually, I don't want the equal. So everybody, instead of the equal, that's where you want to go to the keyboard and do the wavy. Okay. And I'm going to hide the keyboard. So click on this to hide the keyboard. We also want to go to the front for the graph settings. And I'm just going to do a quick one. So I'm going to do 0. Our highest temperature is 100. So I'm going to do 110. You always want to do a little bit over. And then 100. And the most she sold was turning 43. So I'm going to do 250. Okay. So as you all can see, this is a pretty good line of best fit. It's close to most of the data points, pretty close. Okay. This R value, everybody, is called our correlation coefficient. So for that, everybody, so remember we're using R, not R squared, okay? So the correlation coefficient R shows how closely the line fits the data. And then this is what we're going to use. So we need the slope, okay? And we're going to round it to the hundredths place and our y-intercept. So that's going to give us our equation. So we have y is equal to mx plus b. And I'm just writing those values down, and I'm going to show you how we're going to use those. Okay. So we're going to round it. So remember, we're going to round it to the hundredths place. So everybody, that's always 2 decimal places. So 5 and up, round it up. So we're going to round it up to 4 and 44 hundredths. So we look at the number after, 5 and up, round it up. So it's going to be for our y-intercept, so 187, 67 hundredths. Okay, so 5 and up, round it up. And now we can write our equation. So our equation is going to be y is equal to 4 and 44 hundredths x minus 187 and 67 hundredths. Okay, so you ask, why would we use this? Well, you think about it, businesses would use this to help them predict how much how many items they're going to sell, to make sure they have enough in stock. Okay, so if Sophia is stocking her concession stand. Okay, so if Sophia is stocking her concession stand, okay, and the temperature reaches 106 degrees. Nice cool day for us right now. How many water bottles does she need? Okay, so how many bottles? I'm going to put it over here. How many water bottles should she expect to sell? I'm just writing it over here because. Okay, so we're going to go ahead and substitute it in, everybody. So we're going to substitute in. Okay, so our x value. Okay, so 106 is our x value. So we're going to substitute that in for x. So I'm going to go y is equal to 4 and 44 hundredths times 106 minus 187 and 67 hundredths. We put that all in the calculator. We got 282.97. Okay, we're going to round it up, everybody, to the nearest whole number because we're not going to have part of a water bottle. So I'm going to round it up. So it's going to be approximately 283. Okay, so 283 water bottles is how many she should expect to sell. Okay, so next part, everybody, is we're looking at slope. So our m value, well, what does it mean? Okay, so we're going to look at interpreting slope. Okay, so X is the daily temperature. Okay, and then Y is the number of water bottles. Sold. Okay, so we have our equation again is Y is equal to 4400 X minus 187 and 67 hundredths. Okay, so so Sophia's looking at this, and what she wants to know is how many water bottles will be sold if the temperature is increased by 2 degrees. So again, think about it. She has a business. She wants to make sure she has enough, but not too much stock left over. Okay. So we have slope is going to be equal to, and it's the change in y over change in x, and everybody, that's just the Greek symbol delta, which just means change. Number of water bottles sold. Over the temperature. Okay. So we're always going to put whole numbers over 1, everybody. So that means that 4 44 hundredths bottles over 1 degree. Okay, so that's going to be approximately 4 water bottles. So Sophia is going to sell 4 more water bottles per 1 degree increase in temperature. Okay, so what if it increased by 2 degrees? So if it increased by 2 degrees, everybody, so we're just going to take 4 times 2 degrees. Okay, so she'd expect to sell 8 more water bottles. I have to write a question for this. So how many bottles will be sold if the temperature, so how many more water bottles is Sophia going to sell if the temperature increases by 2 degrees? By 2 degrees. Okay, so this next part, everybody, so we're going to look at the correlation coefficient. Okay, so correlation coefficient, so that's our vocabulary word that we're using. Okay, and we use the letter R for that, and that shows how closely the line of best fit fits the data. Okay, so what is R? So we use the letter R, everybody, not R squared. Okay, and so our correlation coefficients that we have, everybody, so if it's strong, and it can be positive or negative, and it's going to be the absolute value of 75 hundredths or greater. If it's weak, again, it can be positive or negative, and it's going to be 3/10, the absolute value of 3/10 or less. And then moderate is going to be all the other positive and negative values. So moderate is all the other positive and negative values. And I will show you this on the number line. So we're still working on regression. And over this is the last part of the note. So okay, so we're going to use a number line. I'm a visual person, so we're going to figure that out. So let's see, this is about halfway. We're going to have -1, 0, 1. Then we need to do about what 3/10 would be. So -75/100, -3/10. And then, I know this is estimating, and then +75/100. Okay, so now we can put our values on there. So if it's strong, it's going to be between -1 and -75/100, including that number. And then again, strong again on the other side, between 75/100 and 1. Okay, if it's moderate, okay, so moderate is going to, remember, it's going to include all others. So in between -75/100 and -3/10, and then between -3/10 and -75/100. And then if it's weak, it's going to be between -3/10 and 3/10. Okay, so on here. Okay, so let's look at some values. So if we go back to our decimals one, so y'all see we put in our values for Sophia's concession stand. So her R value is 0.09722. So if I write that down, we're just going to use 2 decimal places, everybody. So that would be, you'll see it would be over here under strong. Okay, so that would fall under a strong value. Okay. If we had where it was -21/100, you'll see that would fall under right here. So that would be weak. So we're describing the correlation, okay, using our R value. If it's 55/100, okay, that's going to be, that would be right here. So that would be moderate. If it was -99/100, everybody, so that would be right here. So that would be a strong value, a strong correlation. Okay. Okay, so with these, so this is describing the correlation. Okay, so everybody, you got this. And just remember, we're always going to write our summaries, but you want to do it the next day after, so you can review your notes again. Okay.